Well, why did we get a solution that works and a solution that doesn't work? When we did this, we said that we needed to square both sides in order to solve it. So the process used in solving it led to an answer which did not work. It is, however, the root of a non-radical formed by squaring the original function. If you remember, when we put them in, a quadratic is going to look something like this. But my radical looks something more like this. And the difference here is when we squared both sides in order to solve it, we added the negative values for x that don't actually exist in my original function. So radicals can't take a square root of negative. But if I squared to get rid of the radical, then a quadratic can be positive or negative. So, like I said, if I take the square root of 3 squared and 3 squared, this is going to give me 9, this is going to give me 9. So they both give me the same solution here, but negative 3 and positive 3 are not the same thing. So the key here, you don't need to worry too much about it, is to know that we can have an extraneous root or extraneous solution, which happens quite frequently when we're doing this. So if you don't verify your solutions and check to make sure they work with the original equation, your answer can just be wrong. So our process is always the same. Isolate the radical, square both sides of the equation to get rid of the radical, solve the equation, and sometimes we'll wind up, if we have two radicals, we could square it and still have a radical left over, and then we have to do the process again, and then check for extraneous roots. So, looking at example 3 here, I have the square root of x plus 3 and the square root of 3x minus 5. The radical is already isolated, at least one of them is. So I'm going to square both sides. And that's going to leave me with x plus 3 is equal to 3x minus 5. I'm going to move the x's to one side, so I'll subtract 3x's from both sides to get negative 2x on this side. And I'm going to subtract 3 from both sides to get negative 8. And when I divide both sides by negative 2, x is going to equal 4. Now I need to prove that this works. So I'm going to say that the square root of 4 plus 3 is the same as the square root of 3 times 4 minus 5. 4 plus 3 gives me the irrational number, square root of 7. 3 times 4 is going to be 12 minus 5. And the square root of 7 is equal to 12 minus 5 is going to be 7. Square root of 7 is equal to square root of 7. Left side is equal to the right side. And the solution absolutely works. What about the next one? I'm going to square both sides because the radical is isolated. This is going to give me x minus 3 is equal to 3x minus 5. I'm going to subtract 3 from both sides and get negative 2x, and add 3 to both sides to get negative 2. And x is equal to 1. Then I'm going to double check this, saying that the square root of 1 minus 3 is equal to the square root of 3 times 1 minus 5. 1 minus 3 is the square root of negative 2. And at this point, that's not a real number, which means that that can't possibly be true. It exists outside of our restrictions where x would have to be greater than 3. Well, what if I have two variables and a constant? This means that when I square both sides, it's going to get rid of one radical but not the other. Let's take a look at how that works. So the first thing is, I typically isolate the more complex variable, which in this case would be this one. Sorry, not variable, radical. So I'm going to say that the square root of x minus 3 is equal to 5 minus the square root of x. Then, when I square it, I got to make sure I put brackets around it. And you need to remember that that would be 5 minus root x times 5 minus root x. If you get 25 minus x, your answer is wrong. So on the one side, I'm going to have x minus 3. On the other side, when I FOIL it out, then I'm going to get 5 times 5 is 25 minus 5 root x minus 5 root x, and negative makes positive, and root x makes x. And then what we see is we still have radical in here. So what am I going to do next? I am going to move everything that is not that radical to the left-hand side. So I'm going to subtract 25, and I'm going to subtract x from both sides, which means that the x's here will cancel each other out. And when I subtract 25 from both sides, then that's going to give me negative 28 is equal to negative 10 root x's when I combine those. If I want, I can say that it's going to be positive because I can just get rid of the negative on both sides. 28 is equal to 10 root x. I'm going to divide both sides by 10, which is going to give me a reduced fraction of 14 over 5 is equal to the square root of x. And then what am I going to do? I'm going to square both sides again. To get rid of the second radical. So x is going to be 196 over 25. Can't reduce that fraction. Well, now I need to prove that it works. So I'm going to say that the square root of 196 over 25 plus the square root of 196 over 25 minus 3 is equal to 5. Well, we already know the square root of 196 over 25 is going to be 14 over 5 because we squared them out. On the part on the right, I could rewrite 3 as 75 over 25. And when I subtract those two, this is actually the square root of 121 over 25. Or 11 over 5 when I take the square root. 14 over 5 plus 11 over 5 is 25 over 5, which just gives me 5. My left side equals my right side. And I know this works. All right, go ahead and get some practice done.